Okay, in the part one of section 3.3, we saw how to find the standard deviation and the variance for a set of sample data. We found the standard deviation for a random sample of 8 NCAA football coaches' salaries, and it turned out that the mean salary was about 458,000, and the standard deviation was about $372,000. Well, how do I determine if $372,000 is a large standard deviation? We really haven't talked about what standard deviation means. There are two rules that you can use to interpret a value of a standard deviation. They're called the range rule of thumb and the empirical rule for bell-shaped distribution. The range rule of thumb is based on the principle that for many data sets, the vast majority, such as 95% of sample values, lie within two standard deviations of the mean. Now, let me make sure you understand what that means. Let's say I was talking about a sample of test scores, and the mean of my sample was 80. X bar is mean, and the standard deviation for my set of test scores, sample set of test scores, which is S, is 10. Let's say I was just given that information. If one standard deviation is 10, then what would the value of two standard deviations be? Well, if one standard deviation is 10, two standard deviations would be 20. And what the range rule of thumb is saying is that 95% of test scores would lie within 20 points of the mean. 20 points below the mean would be the mean minus 20 points, or a test score of 60. 20 points above the mean would be the mean plus 20, or a test score of 100. So what the range rule of thumb is telling us is that 95% of all scores would be between 60 and 100. That is what I mean when I say within two standard deviations of the mean. Now, it's time to give an official statistical definition to unusual. So far, we've just kind of relied on our gut instinct. Does this seem like it's unusual? Does it not seem like it's unusual? But in statistics, we have an official definition for what we consider usual and unusual, and it's based on the range rule of thumb. If scores are within two standard deviations of the mean, such as on this previous example, if scores are between 60 and 100, they're going to be considered usual. Not shocking, not surprising. But if scores are outside the range of two standard deviations from the norm, then we're going to consider those scores unusual. We would say it's unusual for someone to have scored a 50 or a 40, but scores between 60 and 100 would be considered usual. We can find the lowest usual value just like we did on the previous example. We said the mean was 80, one standard deviation is 10, so two standard deviations is 20. The lowest usual value would be the 60 minus two tens. I'm sorry, 80 was the mean. 80 minus two standard deviations is 60. And then find the maximum usual value by adding two standard deviations to the mean, and that's where we came up with the 100. Any scores between 60 and 100 are usual. Any scores less than 60 or greater than 100 would be unusual. So here's an example. The systolic blood pressure of 40 women have a mean of 110.8 milligrams of mercury and a standard deviation of 17.1 milligrams of mercury. Find the range of usual systolic blood pressure readings for this data. First, identify what we're given in the problem. The mean, and this is a sample of 40 women, the mean for this sample of 140 women is 110.8. And the standard deviation for blood pressure of these women is 17.1. We want to find the range of usual systolic blood pressure readings. The lowest usual blood pressure reading would be 110 minus 2 standard deviations. That's 110 minus 34.2, and that's 75.8. I said 0.8 and wrote 0.5. The maximum usual or non-shocking blood pressure would be 110 plus 2 standard deviations. That's 110 plus 34.2, and that's 144.2. So the usual range of blood pressures that we would not be surprised at, blood pressures we would not consider unusual, would be anything between 75.8 and 144.2 millimeters of mercury. That's what we're going to consider usual systolic blood pressure. So, would a woman who had a systolic blood pressure of 181 millimeters of mercury be considered unusual? She's a good bit higher than that 144.2. So, yes, that systolic blood pressure should be considered unusual. She may even need to dial 911 as we speak. There's also a range rule of thumb for estimating a value of the standard deviation. As long as we have all of the data values, we can get an accurate standard deviation on the calculator using the standard deviation function that I showed you. But if we only know the range of the values, we only know the highest and the lowest, then we can't get an accurate standard deviation. The very best we can do is estimate it. And the range rule of thumb says that the best way to estimate the sample standard deviation is just take the range and divide it by 4. Now, range was the highest value minus the lowest value. So do that subtraction, then divide by 4. That is an estimate of the sample standard deviation. Truly, it's not a very good estimate. It's not very accurate, but it's the best thing we can do if we only know the highest and lowest values of our data set. Let's use it to estimate the standard deviation for Rhone State professors' ages. And I made this data up. I don't know that it's accurate. But if Rhone State professors range in age from 26 to 70 and their mean age is 50, estimate the standard deviation of ages of all Rhone State instructors. Here are the keywords: estimate, standard deviation, and I don't know the age of all professors. I only know the lowest age and the highest age, the youngest professor and the oldest professor. So the range rule of thumb says the very best I can do is find that age range by subtracting 26 from 70 and then divide by 4. The 4 was just in the formula. 70 minus 26 is 44. There's a 44-year age range of Rome State professors. Divide that by 4, and you get that an estimate of the standard deviation for Rome State professors' ages is 11 years. That is not likely to be accurate. It's just the best we can do with the information that we were given. We're also asked within what age range would 95% of all professors be? Well, this is our very best estimate of the standard deviation, 11 years. So two standard deviations would be 22 years. And the range rule of thumb says that 95% of professors would be within this two standard deviations or 22 years of the mean. The mean was 50. And so 95% of the professors would be between 50 minus 22 and 50 plus 22. That's between 28 years old and 72 years old. 95% of professors would be between 28 and 72. Any professor younger than 28 or older than 72 would be considered unusually young or unusually old.